good day, geometry. We are continuing our trek through missed algebra with CO10, simplifying an expression with exponents when multiplying by the same base. The good news is you did this before last year in PO44, and it kind of ties directly to it, which is also on your entrance exam for this year. So if any of these rules are going to kind of click, like, oh, I gotcha, then it's going to be this one here, okay? We start with defining what simplifying means, and this, to simplify something is the same whether it's a fraction or an expression or now involving powers. What does it mean to simplify something? Caleb?
To break it down into a simpler number.
Yeah, basically to write it a simpler way. When we talk about expressions, it's combining like terms. Remember, distributive property, combining like terms, okay? When we talk about exponent expressions, to simplify is to combine, I should say like bases. Gotta be careful there. Combine like bases and coefficients. Okay? Combine like bases and coefficients. Yesterday we talked about what a base is. It's what's attached to the power. We talked about what coefficients are. It's that number out in front of the base that's not affected by the power. So in this first example here, 3 to the 4th times 3. We want to simplify this. And the reason why we spend so much time on expanded form in PO9, and the reason why it's a power objective, is because all the rules that we're going to talk about can be explained using expanded form. Okay? 3 to the 4th times 3 says we're taking 3 to the 4th, which is 3 times 3 times 3 times 3, and multiplying that by that other 3. How can we rewrite that to be simpler? Mackie? 3 to the 5th. Okay? And you can clearly see that when you write it out in expanded form, like, yeah, I've got 5 3s that are all being multiplied together. That's the definition of 3 to the 5th power. Okay? Let's look at number 2. 7y cubed times y to the 4th. Well, 7y cubed, that's 7 being a coefficient, so there's only one of them. But then y times y times y, right? 7y cubed in expanded form. And then y to the 4th is 4 more y's. How can I write that as one expression? Simplify it. Alex? Adam? Oh, it's going to, my apologies. 7y to the 7th, right? I've got my coefficient of 7. There's only one of them. And I've got 7 y's all being multiplied together. I can write that as 7y to the 7th power. Number 3, the last one there, 8x squared y squared. Again, 8 being that coefficient. There's only one of them. Then I've got 2 x's. I've got 2 y's. Then I'm multiplying that by 5x to the 4th y cubed, which is a coefficient of 5. There's only one of them. And then 4 x's and 3 y's. Whew, just fit. Okay? Now, the reason why simplifying with exponent expressions is combining like bases and coefficients is, remember, the only operation here in expanded form is multiplying, right? And what do we know about multiplying stuff? You can do it in any order, okay? So to simplify this and combine the coefficients, 8 times 5, 40. What's the joke? Turn around, okay? And then when it says combine like bases, notice I've got 2 of them here. I've got a base of x and a base of y. I can't combine x and y together, but I can combine my x's with my x's and y's with my y's. So how many x's are there total in that expression when written out in expanded form? Drake? 6 of them. Okay? So x to the 6th. And how about y's? Mackie?
5.
Which is y to the 5th. Okay? So, as much fun as it is to write expressions out in expanded form over and over and over and over again, we've got better things to do with our lives, like play Mario. Okay? So if there is a pattern or a shortcut, I'm all for it. Does anybody see anything that stand out to them as like, hey, well, instead of doing this, why don't I just do this, which takes a whole lot less time? Peter?
If like you add the coefficients.
Not add the coefficients. The exponents are added. Notice how, in this first example, 3 to the 4th times 3, what's the exponent with that second 3, even though it's not written? 1, that lovely 1. I think on my hidden math poster that Caleb found today, yeah, the yellow section there, says there's an exponent of 1 on every whole number, right? 10 is the same as 10 to the 1st. So this 3, which is really 3 to the 1st, those exponents added, 4 plus 1, gives us our final exponent of 5. That's cool. On the second one, y cubed times y to the 4th, add those powers, 3 plus 4, gives us y to the 7th, which is what the exponent is in our final answer. The third one there, looking at our x's, we've got 2 and 4. 2 plus 4 is 6. You see we have that power there. And then on our y's, 2 and 3, 2 plus 3 is 5, and that's the exponent there. So our rule, what patterns do you see here? When multiplying by the same base, the exponents are added. Okay? This can go on a help sheet here. This part can't, the happy pencil section, but the patterns that we found, that can go on a help sheet. It is a key point. What about the coefficients? What about the coefficients? Blake. Oh, sorry, that was I thought it was Hamlet. Will. Multiply. Okay. Multiply. The easiest one to see that is in the third one, because 8 times 5, our coefficients give us 40 here. Okay. In the second example, what's the coefficient to that y to the 4th? What's the hidden math? I was so happy when I found that poster. Yeah, it's a 1. Okay, the orange section on the hidden math poster back there, right? X is the same as 1x. Y to the 4th is the same as 1y to the 4th. So our coefficient 7 times 1, it still holds. Okay, what's the coefficient in the first example there? 3 to the 4th times 3. Blake? If 3 was a coefficient, then why don't we have 9 to the 5th here? 3 is a base. The first 3, this 3 here, well, that's not a coefficient because the power is attached to that 3, right? There really isn't one. I mean, you could say that you've got coefficients of 1 on each of these, 1 times 3 to the 4th and 1 times 3 there, but it's also correct to say there aren't coefficients here, right? Which is why nothing gets multiplied. This 3 stays a 3, doesn't become a 9, but the powers are added. Which leads us to the last one, which kind of cut off my page here, but you can see it on yours. The base, what happens to the base? What happened to our base of y here? Let me use a different color. What happened to our base of y here between our expression and our answer? What happened to our bases of x between our expression and our answer? What happened to our bases of 3 between our expression and our answer? Peter? Yeah, they didn't change. Your base stays the same. Okay? This is where a lot of people get tripped up by this rule because they see something like 3 to the 4th times 3 and they put 9 to the 5th because they're treating that 3 like a coefficient, but it is not. The power is attached to it. Therefore, it is a base, and the base stays the same. Does not change. Okay? How are we doing? Questions? Okay. Let's go on to sum to practice. On the front side of this, I am requiring you to write each expression in expanded form first. I'm sorry. But then on the second page, you don't have to anymore. Second page, you can just go straight to the rule. But I want to get you, trust me, 76ers, trust the process, right? That knowing expanded form and being able to write an expanded form is helpful, particularly to avoid you seeing this, writing it as 36 to the fifth. Because when you write this out in expanded form, 6 times 6 times 3 more of them, you would not write 36 to the fifth power. I mean, there's no 36 anywhere in there, right? So by practicing with expanded form, it helps you avoid that big mistake. So 6 to the fifth power. Okay? Any on this first page that you want to go over specifically? Michael? Why not? Of course. Okay? So we have 1/2 a to the fifth times 200a squared. Our coefficient to that first term is 1/2. There's only one of them. And then we have 5 a's all being multiplied together. Okay? And we're multiplying that by 200 and then times a times a. Before we finish this out together, take a minute and just ask yourself, what are my coefficients? Multiply them. What are my powers? Right? How many of my base do I have? How many a's are there? And see if you can do it yourself. I know that the fraction kind of, but who'd like to share what they came up with? Drake?
187.
Very good. 1/2 times 200, or 1/2 of 200, is 100. Coefficients multiplied. And then we have 7 a's all together, which gives us 100a to the 7th. Following our rule, coefficients, 1/2 times 200 is the 100. Add the powers, 5 plus 2, base doesn't change, a to the 7th. Okay? Others on this page that look particularly entertaining. Yes?
I just have a question. So like on the 14x times 10x, would you just do 14 times 10 and then add the x's?
So written out in expanded form, right? Because you have to do that too. Yeah. But yes, you would take 14 times 10, which is 140. And then what's that exponent on that 14x? It's hidden, Violet. It's a 1. So writing out in expanded form, you can clearly see you've got 6 x's there. Okay? But adding the powers, the shortcut works also. 1 plus 5 gives us 6. Others? Question or no? The negative 8y? Okay. Negative 8y times negative 2x cubed. Written out in expanded form. We have 8 times y, negative 8 times y, times negative 2 times x times x times x. So our coefficients, which we can see, negative 8, negative 2, they get multiplied, give us positive 16. And we look at our bases. And remember, way back at our definition for simplifying, it was combined like bases. X and y are different bases. So we can't really combine them. We have to keep them separate. And it would be most proper to write that as x cubed y. Because remember, standard form, you've got the higher exponent first, okay, which would be the x cubed. Joe?
Making us write all those twos is kind of cool.
It's not that bad. I mean, there's only 7 of them. Sorry. Remember, this class is for high school credit, so blame the high schools. Caleb?
Can we do the 7ny?
Sure. 7ny squared times 2n squared in expanded form. 7 times n times y times y. That exponent only applies to the y. There's only one 7, there's only one n. And then times 2n squared, which is 2 times n times n. So first we look for our coefficients, 7 and 2. They multiply to give us 14. Look for our like bases. We have 2 of them. How many n's do we have total? Good, 3. So n cubed. How many y's do we have total? Excellent, 2. So y squared. So 14n cubed y squared. That is the best order, again, that higher exponent first, but if you put y squared n cubed, there are worse things you could do. So, okay. The second page. More of the same. Joe should be very thankful I'm not having you write it in expanded form for this one, because I think somewhere on the page I've got like 100 or something. Maybe that's on the review page, but we have 5 and 2 and 10 and 13. So yeah. All right. So yes, you don't have to write it in expanded form here. You can just use the rule. But what any of these that you want to talk about, Blake? We'll get to that one next. But any of these 8 or however many there are you want to talk about in this main section? Drake.
So on the first row,
Yeah?
we're just adding them, right? There's no catch?
No, there's no catch.
Yeah.
No, there's no catch. There are no coefficients to deal with, so yeah, it's really just adding the powers. Do you think that I take joy in tricking you?
Yes.
That's true. But not this time. There's no catch here. Yeah. Any of that you do want to talk about though? No? Gino? We'll talk about those in just a second. Any of these 12 though? No, all right, that's fine. The bottom section here says fill in the missing exponent or exponents. So here you're almost solving an equation. You know, once you kind of know the rule for a power, n to the what times n to the 5th is going to equal n to the 11th. You know, if you know the rule and you say, well, how do I get that 11? I get that 11 by adding the powers. What does that first exponent have to be?
So you have to take 11 and take away the 5, and then whatever you get is what's in the box.
Which is?
6.
There you go. It's got to be a 6, right? N to the 6th times n to the 5th equals n to the 11th. So it's kind of it's solving an equation for an exponent, you know, when you know what that rule is. On the second one, you've got your exponent for y and x to solve for. Third one is a y. And the fourth one, not a trick per se, but it is requiring you to draw on previously learned material for that last one there. So we won't call it a trick, we'll call it a treat. Spirit of Halloween. Doesn't sound quite right. Yeah?
It wouldn't just be n, would it?
No. No. I mean, think about it. You know, if you were to just take away those, because really the rule is you add the powers. So it's kind of like 8 plus the missing exponent, right? Plus 5 has to equal 9. What number would make that equation true, right? That's kind of how you can break it down to be. No. Don't put that. This homework is not going to be due until Monday because tomorrow is a retake day, if I forgot to mention that earlier. Any objectives that you have, the entrance exam practice work has been posted on Google Classroom. You can print it out. You can work on what you need to work on tonight, bring it tomorrow. You can do the retakes. If you have no retakes to do, New Khan Academy will be assigned, Gino, and you can work on the New Khan Academy tomorrow. But if you bring practice work already completed, you can do the retakes tomorrow, or you can work on practice work tomorrow during class. I'll update grades over the weekend. I don't know how many objectives were on your test off the top of my head. I don't remember. 35, I think. So however many, whatever, we'll say it's 35. If you didn't pass 5 of them, that means your score is 30 out of 35, and that's what's going to go into Educate. If you do some retakes tomorrow and pass 2 of them that you didn't before, then your score will bump up to a 32 out of 35. So anything you can do tomorrow before grades are officially updated will look better. But this will be due on Monday because tomorrow will be a retake day. Yeah. Math packets are due the 28th. If you gave it to me to correct, I'll get it to you probably Monday. But you have next week to turn them in also. Anything else? Gino, what do you got? You're talking, so I assume you have something to say. Okay, then no talk. All right, folks, that is how you math.